All right, so now let's consider the 2 norm of x, and let's consider the square of the 2 norm of x. What's the square of the 2 norm of x, Sarah? What is the 2 norm again? Let's think about the 2 norm. It's over here too.
Okay, it's the dot product of.
Oh, that's awesome. Okay, so we have this famous formula. We should actually mark that as a famous formula to be remembered, because it's going to show up a lot. And of course, I just deleted the algebraic properties of the inner product, which sucks. All right. All right, and what does it mean, x inner product itself? If we were to look at that, it means x1, x2, all the way down to xn. How's the size of my writing for folks in the back? A little small? Everybody in the front is like, yeah, I got it, I got it. Theo? It's a little small. Nemanja? Blake? Yeah, Shakira? All right. All right, so what's this now? What does that look like? x1 times x1 plus x2 times x2. Am I allowed to say times in this case, Shakira? xn times xn?
Actually, yeah.
Why am I allowed to say times on these ones? Yeah, awesome. How about up here?
No.
Yeah, I guess I could, but then I'd confuse myself, right? Or more importantly, I would confuse the mathematician I'm speaking with, which in this case is myself. What's this one? You got it. All right, so now what's this? What does this look like here? And maybe you'll ask, Rikaku, what's this one if I say x1 times x1? x1 squared. And then the next one, what's the next one? All the way down to xn squared. What do you know but x sub I squared? What do you know about x sub I squared if x sub I is a scalar? What's the smallest the square will ever be? 0. So you know that this thing is greater than 0, which implies what? That implies immediately that the square of the 2 norm must be greater than 0, because this is a sum of a bunch of things that are no less than 0, right? And what does it mean if the square of the 2 norm is greater than 0, greater than or equal to 0? What does that mean immediately? Yeah, it must mean that the 2 norm is greater than 0 or equal to the 0. Can you conclude right now that it's only equal to 0 if and only if the entire vector is 0? How would you make that conclusion? Question, is it possible to have a non-zero coefficient, square them, sum them up, and get 0?
No.
Why not? The moment you have something that's non-zero and you square it, not in finite precision arithmetic, but in actual arithmetic, the moment you have something that's non-zero and you square it, what happens? It's positive. Which means that if you put that into the sum must be positive. In other words, another way to say that is, if I sum a bunch of squares and I get 0, what must be true about the individual summands in that sum? They all must be 0. What's the inverse image of a square that's equal to 0? What's the thing that you square? 0. Which means every one of the coefficients, if the sum of the squares is 0, the coefficients must themselves be 0. Done. Yep.
In the bottom line, how are you getting from the second part to the third part? Because are you saying you're taking the
Square root of both sides.
But a square root can give you a negative answer, something like this.
Well, I mean, I guess the thing that the other way to think about this is that, yeah, so formally speaking, if we say that square root is a function, then we agree that that function has either one of the 2 traces, and then we as a mathematical community, if I asked you this problem, what would you say? Would you say that this is an answer to that? Sorry. Yeah, would you say that -4 is an answer to that problem?
The negative is within.
Now we're just playing, right? Yeah, would you say that this is an answer to that problem?
I think 4, but sometimes you do say plus or minus 4
depending on the context, right? Yeah, but the other thing though is that I mean, I guess you could think through this, right? You could think through.
If you want to do a function, you choose the positive.
Yeah, but more importantly though, that when you're looking at the square root of this thing, by definition, this internal thing must be positive.
Yeah.
The pre-image has to be positive. There's no way that the pre-image was negative, and therefore there's no confusion.
Yeah. No,
Yeah. So that from that standpoint, yeah.
But it's like still the square root of a positive doesn't have to be positive. That's
Correct.
Yeah.
But if you know the argument was positive to begin with, what would you say? It must be positive. Yeah.